In this second part of section 11.1b, we have to consider the third scenario. What's going to happen when we can't simplify the denominator and the numerator by canceling, and as well, the denominator is not a perfect square? Then we need to do something that is called rationalizing the denominator. This occurs when you don't have a perfect square in the denominator by multiplying the numerator and denominator by the same radical expression. That will make the problem simpler. So, what is our goal? Very simple. Our goal is to make the denominator a perfect square. How do we do that? Well, we're going to have to multiply by a number or a number and a variable to accomplish this. And I'm going to show you how to do this. For example, if I multiplied 5 times 5, I would get 25. So, I'm going to multiply the numerator by 5 and multiply the denominator by the same thing, because this is the equivalent of multiplying by 1. Now I simplify my numerator. In the numerator, I now have 2 root 5. The denominator, however, I now have root 25. Since the denominator is a perfect square, I can simplify it, and that gives me 2 root 5 over 5. Some people may want to cancel the inside and the outside of the radical, but you can never cancel something inside a radical with something outside. So this is our answer, just like that. We've satisfied the rules of radicals because there's a fraction no longer in the radical, and we don't have a radical in the bottom. Our second problem is a little bit more unique. We don't want to necessarily multiply by the square root of 8n by the square root of 8n. We say, what's the smallest thing that we can multiply by to get a perfect square in the bottom? Well, if we look at our perfect squares, 1, 4, 9, 16, 25, and 36, we can look at them and we can say, oh, if I multiply by 2, 8 times 2 will be 16. So I'm going to multiply the top and bottom by root 2. However, I still have the n to deal with. I need to have either n squared, n to the 4th, n to the 6th, n to the 8th, n to the 10th, or n to the 12th, or so on, as a perfect square in the denominator. Well, I could have n squared, so I'm just going to multiply by one more n to get my perfect square. Now, we combine and go from there. The top becomes 14n. The bottom becomes the square root of 16n squared, which is a perfect square, and that's our goal. This gives us an answer of the square root of 14n over 4n. Once again, our goal was to get the denominator to be a perfect square for both parts, which then we could take the square root of. Let's look at number 9. We have to think 10 times what is a perfect square? Well, in this case, it's just 10 times 10, so we're going to multiply top and bottom by root 10. Our numerator becomes 70x. Our denominator, the square root of 100. Does this simplify? It sure does, but the numerator doesn't break down any further, because 70 is just 7 times 10, and that's not a perfect square. So the numerator stays the same, but the denominator becomes 10. Now remember, the 70 and the 10 don't cancel because one's in the numerator and one's in the denominator. And one's inside the radical and one's outside the radical, more specifically. Let's look at our bottom 3 examples as our last problems. 3 over the square root of 2. We could say 2 times 2 is 4, so let's multiply top and bottom by root 2. That gives us 3 root 2 over root 4. And root 4 is 2, and so there's our answer. What do you think you need to multiply 12 by to get a perfect square? If you're thinking your goal is to get to 36, you were right. So you multiply by 3. We do need one more x to get x squared, and so our numerator becomes 4 root 3x. Our denominator becomes root 36x squared. Now, our final answer is 4 root 3x over 6x. But in this case, we have a special scenario. Do you realize that the 4 and the 6 are both outside the radical? And the 4 and the 6 can both then be canceled. That leaves us a final answer of 2 root 3x over 3x, because the 4 and the 6 became 2/3. So there's our final answer. 2 root 3x over 3x. Our last one, we have root 5y over root 6. And what I've just done is broken it up into 2 parts. I'm going to multiply the bottom and the top by root 6 because that's going to give me the square root of 36 as a goal on the bottom. The top's just going to drag along and become root 30y. Well, with the top dragging along is root 30y, the denominator instead becomes just a simple 6, and so there's our solution there. So rationalizing the denominator has a lot of different possibilities, but the goal is to get a perfect square of both number and variable to do so. And you're going to often have to multiply by something to do it. In some cases, you may be able to simplify when you're finished with the problem.